In this video, we're going to look at all the different things you need to do with your Ti-84 on the Applications Interpretations exam for the SL course. So these are the topics we're going to go through, and we'll start with the first thing you need to do at the start of the exam. They're going to reset your calculator when you start the exam, and so it goes back to default mode. So the first thing you want to do is click Mode, and you want to change your calculator into degrees. So you hit Enter, and then you want to make sure also down here Stat Diagnostics is on. If you don't do that, you get all the trigonometry questions wrong if you're not in degrees. And stat diagnostics, that's how you see the R value when you're doing a linear regression. So that's the first thing. Now, in general, when you're entering numbers in, there is a difference between this negative button down here and the subtraction sign. So if you're putting in a negative number, make sure you put that. So if you have -5, especially if it's going to be an exponent or something like that. The other thing you want to make sure you do is when you're dividing things, especially things in fractions, especially if there's multiple terms, you need to put the numerator in brackets and the denominator in brackets. So for example, the correct way to solve that question there would be putting 11 plus 3, close the bracket, then divide by 7. And that way it'll do it in the correct order. If we had done it 11 plus 3 without the brackets divided by 7, you see that you get a different answer, which is the incorrect answer. So make sure numerators in a bracket, denominators in a bracket. Scientific notation is how you write large and small numbers. And the way we do that is if we wanted to put 4.45 times 10 to the power of 8, we go 4.45, and then we hit this button here, second and comma. You see it's the double E here, but up here it gives us an E. And then we type in the exponent 8. And so that way we don't have to do times 10 to the power of 8. And when we hit enter, we see that's the number we get. When we do like a large number, 52 to the power of 10, for example, it reports the answer in scientific notation for us. And so what we would write is 1.45 times 10 to the power of 17. So when you're writing answers on your tests or exams, don't put the E, you write times 10 to the power of 17. A very useful app for us is going to be the finance app, and so that's any sort of compound interest question, and you can find that by clicking apps, hitting 1 for finance, and then 1 for the TVM solver. And now it gives you all these values you need to input. So the number of compounding periods, interest is a percentage, so if it tells you the interest is 3.4, type in 3.4. Don't write it as a decimal, and then you fill in all the other values as needed. And when you need to solve for something in this, once you have your numbers in, you hit alpha, the green button, and you hit enter. You see it has the word solve there. And so wherever you put the cursor, it will solve for that value, assuming that you've put the correct numbers in for all the other ones. To do exponents, to write an exponent, say we want to do 7 to the power of 4, we use 7 and then we use this, triangle here, 7 to the power of 4, and that gives us an exponent. If you want to write E, the letter E, is a constant value, and that's stored in your calculator. If you hit second and ln, here you see e to the power of x, it goes e, and then it gives you a number. You can put in the number that you need. E to the power of 2 gives you 7.38. So that's how you find e. For other logarithms, if you type in the log button here, that is log base 10. So if you have log base 10, you just type log, and then you input your values here. However, if you need another base, you can go to math, and if you can scroll down to A here, log base, and hit enter, it gives you the option to put in a different base. So you can put 2, and then here you put 8, hit enter, you get 3. If you have the base E, so the base of Euler's number there, you go ln here below the log button, and then you can put your values in like that. So that's where you find all the logarithms, the 3 different logarithms. Graphing is really important on this calculator, and there's a few different things you need to do with graphs. So one of the more important things you need to do is find the x-intercepts. And x-intercepts can be all zeros, roots, x-intercepts. It's a solution to the equation. So if we want to find the x-intercept of this one here, I'm going to input this equation. So it's -0.5, x is here. I want to square the x, I use this button, plus 2x again, plus 6. And when I graph this, I should get a parabola opening downwards. And it's asking us to find the zeros. And there are 2 zeros, so we have to do this process twice if we want to find both. I'm just going to do it for one here. But let's say we want to find this one here. We go second trace, and this gives us all our graphing options, all the different calculations we can do. So we're looking for a 0 here. And then it asks us 3 questions. It gives us left bound. And so that means it wants to find a boundary for where this x-intercept is going to be. And so you have to move it along the function where it's left of the x-intercept you're looking for. Then you hit enter. And then it asks you for a right bound. So now you go to the right of where the x-intercept is. You hit enter. And then it asks for a guess. And you try to get close because you want to show which intercept you're looking for. And when you hit enter, you see it gives you the exact value. So this intercept is -2. And then we'd have to repeat the process if we wanted to also find this one. The other thing we're going to be interested in is our maximum or minimum values. And these are also called turning points. So for this one, we wanted to find a maximum. So we hit second trace again. And then we see the fourth option there is maximum. And we hit enter. And it does the same sort of thing. So it gives you a left boundary. So we hit enter here because we're left of the maximum. And then a right boundary. So we have to move all the way over just so we're past it. Hit enter. Doesn't have to be symmetrical. And then we go up, give it a guess, somewhere around here. Hit enter. And there it gives us our maximum x value and the maximum y value. Another thing that you might want to do is you might want to find the intersection of graphs. So if we go back to the y equals, and we want to find the intersection of 2 graphs, this is a great way to solve equations that are complicated, like quadratics and cubics and exponentials. So you find the solution is where these 2 different sides of the equation intersect. So in this case, we're going to put 3.5 to the power of x as one of our functions, and the other one is -2x plus 5. And when we graph that, we should see 2 different functions here. The blue there, that's going to be our exponential, and then the red should give us a line with a negative slope. And we see that they intersect right here. So we want to find that point. What is that point there? So again, we go second trace, go to our calculate, and we look for intersect. And we hit enter. So it asks you the first curve, and you see the equation is here, 3.5 to the x. Is that the first curve? Yes. So we hit enter. Then it asks us the second one, it's the line, yep. And then we give a guess. Now these only intersect in one point, so wherever we guess, it's going to show us that. But sometimes functions intersect more than one point. So put the guess close and it'll look for the one closest to what you're trying to guess. You hit enter and you see, there we go. We have the x and y coordinates of the intersection points. And so that can be a solution to an equation or some sort of word problem. We're going to look at the statistics part of this. So we want to find, for a set of data, the mean, the median, Q1, Q3, standard deviation. Those are all in one place. So all those values you can find in one place. So you hit stat and you choose edit. And it's going to give you these lists, L1, L2, L3. And you type in your values here and you hit all the numbers from your data and you put it all in one list. And then you go stat, calc. In this case, we're going to look at one variable statistics because we're looking at just one variable. We hit enter. Now it's asking us L1. I only had those values here. Now occasionally you're going to have to deal with a frequency table. And so if you put all the frequency values in L2, you can tell the calculator to look at a frequency list. And what it'll do is it'll do this if you type in L2. And where L2 is located is here. So you have to go second 2. And that's L2, that's the frequency list. Now I don't have a frequency list, so I'm going to clear that. But if you need to add it there, that's how you do it. So you hit second 2. Then you go down to calculate, and it gives you this nice list of all the different variables. So this x with a bar over it, that's the mean value. It tells you the sum of the values. It tells you the standard deviation here, this sigma x here. That's the standard deviation. It gives you the minimum, gives you Q1. And if you keep scrolling down, median, Q3, and the maximum. So all that information is there from one process. Now let's say we have a set of data that is two sets of variables, x and a y values. You input those here in L1 and L2, and I'll just make up some numbers here, 8, 3, and 5, and then our L2 coordinates are 8, 1, 7, and then we want to look at some data, like a linear regression for these data points. So we go to stat, we go to calc, and then we choose this one here, 4. We hit enter, and it asks us the x value, the y value. We don't have a frequency list, and we don't need to store this, so we hit enter, and it will give us an equation of the line here. So it gives us in the form ax plus b. So a here, that would be the slope of this line. B is the y-intercept. And then they also give us r, which is the Pearson's product moment correlation coefficient. So when you're looking for the correlation between values, you have this. So that's what you're looking for there, linear regression. If we had stat diagnostics off, we wouldn't see these r values. Okay, the next one is we're going to do some calculations for a binomial distribution. And so binomial PDF, that's where there's a single outcome, exactly number, a certain amount of outcomes. And the way we find the binomial menu is we go second and we hit vars here. You see the group blue there, it's written distributions. So it's all the different types of distributions. And binomial is down here a bit lower. So scroll down to binomial. And that's option A. So we go binomial PDF, we hit enter, then it asks us for trials, p-value, x-value. We paste those in, and then it calculates the probability for us. The same thing is true for binomial CDF. That's the next option below. So if we go second, vars, and we scroll to this one here, B, binomial CDF. Now we can type in binomial CDFs, and it gives us all the values. Same idea, but CDF starts from 0 on the Ti-84, and it'll start adding all the probabilities from 0 on up to the x value that you give it. Some other calculators will give you a range, but the Ti-84 starts at 0 and then adds all those up. A normal distribution is found in the same place as a binomial, so you hit second vars, you go to the normal distribution, and in our case we're going to use only the normal CDF, and when you hit enter, you see it gives you a lower bound, an upper bound, and asks for the mu, which is the mean, and then sigma, which is the standard deviation. Normally those are given in a question. Now, if there is no lower boundary or upper boundary or something like that, then what you do is you input either a really small or a really large number. So if they just say calculate the probability of being lower than this, then on your calculator, your lower boundary, the best thing to do is write negative 10 to the power of 99. So some really small number here, and then you put your upper boundary in as to what it's given, plug in the mean and the standard deviation. And then the same is true if you need to create an upper bound. If it says calculate how many are above this value, then you put 10 to the power of 99 in there. So a really large number. And then it'll calculate everything for you. Now, we also might need to calculate the area, or we're given the area under the normal curve, and we need to calculate what value gives that area, and that is the inverse normal. So if we go second vars again, and we go to the third option here, inverse normal, we hit enter. Now it's asking for the area. Now this version of the calculator, it doesn't give you a left bound or right bound, so it's always starting from the left side, so it's always starting from 0. So if you have a question where you're looking for something in the upper boundary, then you have to do 1 minus that value, because 1 is the area under the entire normal curve. So you have some percentage value of that, and you do 1 minus that to find the area on the left side. So you're always looking for area on the left. Okay, we might also have to do a test for independence, and the way you know it's a test for independence is because there's going to be a table with categorical data, and that needs to be input into a matrix. So if we hit second x to the minus 1, we get the matrix here, and we want to scroll over here to the edit button, because we want to edit this matrix. And so make sure we do edit this one, and we hit enter for matrix A, and then it's asking us the column and the rows. We do rows first, sorry, then columns, rows, then columns. So if you have 4 rows and 3 columns, and you hit enter, you get 4 rows, 3 columns, and you can enter in the values, the data that you're given. Just make sure that you do not put totals for the columns or the rows, because sometimes the tables will have the totals for each. This is just the data only going into here. So then you go stat, and you choose tests, and you scroll down to option C, and that's the chi-squared test. And that's going to be the test for independence. So we choose C, you hit enter, and you see it's giving you the observed value. The expected value you don't have to input. It will do it for you. It'll write all the expected values in that matrix for you, and then you go down to calculate, and it'll give you your p-value, your chi-squared value, and if you want to see the expected values, you can go to the matrix B and look at that. So that's how you do test for independence. So the second kind of chi-squared test is the goodness of fit test. And this is where you have some sort of observed value and then you have some sort of expected value, whether it's uniformly distributed or normally distributed or something like that. So the way we deal with this is we go stat, edit, and then in L1 you put all your observed values, and then in L2 you put all the expected values. Then you go back to stat and you go to tests here again, and you want to scroll down to D, option D, which is the chi-squared goodness of fit test. You hit enter, and then it'll ask you, yeah, observed in L, expected in L2. The degrees of freedom, it wants you to input these, and that's the number of pieces of data you have minus 1. So if you have 9 pieces of data, then the degrees of freedom in this case are going to be 8. Once you plug all that in, you hit calculate, and again, it'll give you chi-squared value, it'll give you the p-value, and you can compare it to that and answer the question. Another type of statistical test we do is a t-test, and so it's a 2-sample t-test. So we're looking for changes in the average of 2 sets of data. Now we're going to do pooled data, so we're assuming that the standard deviation is similar or the same. So what we do is the data we get given, we enter the one set of data in L1, and the other set of data goes in L2. Then we go back to stat and tests, and we want to do a 2-sample t-test, which is option 4 here. And so we need to make sure at the top we're choosing data here because we've just entered 2 sets of data. The list is L1, L2, and then we need to know what kind of sample test we're doing. So we choose one of these options here. If we're just seeing if they're the same or not the same, then we choose this not being equal. But if we have some sort of indication as to one should be higher or lower, depending on what we're testing, then you choose either the mean of the second one is greater than the first one or the mean of the second one is less than the first one. And that depends on the context of the question. And then once we've chosen all that, again, we'll get a t-test value, we'll get the t-value, and we'll get the p-value in which we can compare based on the level of significance. Okay, the last part here we're going to look at is some of the calculus things that this will do. So if you have a function, like a curve, and you type it in, and let's do one like just a normal parabola, x squared plus 3x, something like that. And if we graph this, and say at any given point, we want to know the slope of the line at any given point. It's not like a line because it's changing, so we want to know the slope of the curve. One way we can do that is we go second trace, and then it's this 6 option here, number 6, that's dy dx. So that's the slope of the tangent at a specific point. So when we choose that, it's asking us, we type in which x value are we looking for. So I want to look when x is 2. I want to see, so I hit the number 2, hit enter, and as you can see, it tells me dy by dx at x equals 2 is 7. So it's telling me the slope of the parabola at this point is positive 7. And so that's like the rate of change at that time. So that's one way to do this without taking the derivative. We can find that. The other thing we can do is we can get the equation of a tangent. So it's equation of a line that passes through this point and touches the graph once and only once. And we can do that by picking second program. we can ask it to draw a tangent for us. And so I'm going to hit enter, and then it's going to ask us at what point do we want to do that. So I'll do it when x is 1, and I hit enter, and then it draws a tangent for us. It passes through x equals 1, and it also gives us the equation of the tangent here, 5x minus 1. So it's a very useful function for finding the tangent. The other thing we might want to do is find the area between the x-axis and the curve, between 2 points, let's say. So what we'll do here is we'll check and see if we can find the area between the curve, and we'll give it 2 values here. So it's asking us for a lower limit, so I'm going to say x is 1, and then the upper limit, I'm going to say x is 2, and I hit enter. And this function now will calculate the area, so this blue shaded region, that's the area under the curve between 1 and 2. And so we could be asked to find that. And that's the same thing as finding the definite integral between 1 and 2. Okay, if we want to find a finite integral, so we know the boundaries in the function, we can also use this function here in the math. So we type in math, and we scroll down to number 9, FNINT, which is finite integral. And we can enter in our values. So in this case, we're going to enter in just some function here. So we're going from 1 to 5 for the function, let's say, x squared. And then we need to also put here at the end, we have to put the x, just so the function knows that you're integrating with respect to the variable x. And when we hit enter, it gives us the value. So in other words, this is the area under the curve x squared from x equals 1 to 5. So both of those ways are ways to do it. So that's it. That's a very short, brief review of all the different functions on the calculator. I hope this helps.